Hello, everybody. It's Mrs. Pound, and I am back with the last video for chapter 26 on sound, and it is a short one, but it just didn't really go with the other topics very well. So here we go. Let's finish the chapter. So our objective today is to describe the condition for beats, and that's pretty much it. We're going to talk basically about interference today. So this is review of what we talked about with vibrations and waves. So here I have a picture of some interference patterns, and you remember with our transverse waves, the crest and troughs match up, and so it increases the amplitude. Now, when we have longitudinal waves, like a sound wave where we have areas of high pressure and low pressure, or compression and rarefaction, when we superimpose those on each other and they add up, we get areas where there's way lower pressure and way higher pressure. So that increases the intensity of the sound, which we also call the amplitude. Now, for transverse waves, when a trough matches up with a crest, they cancel out. Okay. However, with longitudinal waves, when we have an area of low pressure matching up with an area of high pressure, then they also cancel each other out because it evens, it averages out. And so you get no sound. So when we superimpose these and they're in phase where we have constructive interference, we get more intense sound, it gets louder. But when they are out of phase, when we have destructive interference, they cancel each other out so you don't hear the sound or it's greatly diminished. Now, interference happens in poorly designed theaters and gymnasiums. And if they're poorly designed, they will have what are called dead spots. These are areas where it's very difficult to hear, which is not good for an auditorium or a theater. And it's due to the sound waves, the way they bounce off the walls and will interfere with one another. Now, the next topic is about beats. And if you are a musician, you know what I'm talking about with beats. This is when we're tuning, we're listening for the beats. So, beats are a throbbing variation in the loudness of sound caused by interference when two tones are slightly different frequencies are sounded together. So we have a duet going on here with a violin and a cello, and they have to be in tune. If they're not in tune when they are playing the same notes, you will hear a throbbing kind of sound. And we call that throbbing beats. And I will demonstrate that in class for you with my flute. I will show you what that throbbing sounds like if you're not familiar with it, if you're not an individual who plays an instrument. But when I am tuning and I tune to another instrument, say a piano or another flute or a violin, that is actually what we listen to for. We play the same note and we see if there is this throbbing. And if there is, we know we're out of tune and we have to make some adjustments. Now, beats are heard by two tuning forks when they have almost the same frequency and are sounded together. And that's not just tuning forks, it's for any two instruments. And I can tell you as an instrumentalist, with my flute, I sometimes have a hard time tuning to certain instruments. Like the piano, I actually have a hard time tuning to that. It's easier for me to tune to another flute or tune to another woodwind instrument. Now, we can actually figure out how off the beats are. So, a question you might be asked, and let's think about this with walking first, is how many times a minute will you be in step with a friend when you walk at 70 steps per minute and your friend walks at 72 steps per minute? And you're probably like, I have no idea how to figure this out. It must be some complicated math. Actually, it's really easy math. You just subtract. 72 minus 70 equals 2. You will be in step with them 2 steps per minute. Okay? So that's it. 2 steps per minute. You just subtract. So let's transfer this over to a Beats problem. When one tuning fork vibrates at 264 hertz and another tuning fork vibrates at 262 hertz, what is their beat frequency? So how often do they match up? It's the same idea, we just subtract. So 264 minus 262 is 2 hertz. Okay, that is their beat frequency, how often they will match up. So that is it. Um, we have met our objective is to describe the conditions for beats, and that's when two tuning forks or instruments are sounding very close in frequency, but not exactly, and you hear a throbbing sound. So you may not be able to get 5 questions for this one, but get as many as you can, okay? A couple of questions will suffice. We're done with the chapter. You have everything you need to start studying for the test that will be coming up. And we'll be moving on to a new chapter.